Welcome to Keen on Science. This is part of my SLOP series, Shed Loads of Practice, as part of your chemistry revision, and this is on the topic of electrolysis. Let's dive straight in.
Question 1. Electrolysis. A student investigated the electrolysis of two aqueous salt solutions. Hydrogen is produced at the negative electrode when the metal in the salt solution is more reactive than hydrogen. State what the student would observe at the negative electrode for each salt solution. And we've got copper sulfate and sodium chloride. So first of all, for the copper sulfate, we're talking about the ions that are going to be attracted to the negative electrode. So we're talking about the positive ions, which are the metals. So the metal here is copper. We're told in the information that if the metal is more reactive than hydrogen, then we get hydrogen. Copper is less reactive than hydrogen, so therefore we'll get copper at the negative electrode. So we'll see an orange, red or brown solid formed, which is the copper. The second salt solution is sodium chloride. Again, we're looking at the positive metal ion because that's what's going to be attracted to the negative electrode. Sodium is more reactive than hydrogen, and we're told that if the metal is more reactive than hydrogen, then we get hydrogen produced. Therefore, we'll see bubbles, effervescence, or fizzing at the negative electrode as the hydrogen is produced.
Question 2 says state the product at the negative electrode, and we're carrying out electrolysis of aqueous salt solutions. So remember, the negative electrode, it's the positive ion that's attracted to that, which is usually the metal ion. And remember, if the metal is more reactive than hydrogen, we get hydrogen gas produced. If the metal is less reactive than hydrogen, we get the metal formed at the electrode. So the first one is copper sulfate. We can ignore the sulfate because that's the negative ion. The copper ion is a positive ion. Copper is less reactive than hydrogen, therefore we get copper formed at the electrode. Second one is sodium chloride. We ignore the chloride. Sodium is more reactive than hydrogen, therefore we get hydrogen formed at the negative electrode. Copper chloride. Copper again is less reactive than hydrogen, therefore we'll get copper formed. Potassium iodide. Potassium is more reactive than hydrogen, therefore we get hydrogen formed. And the last one, zinc chloride. Zinc is less reactive than hydrogen, so we get zinc formed at the negative electrode. Question 3 about electrolysis says state the product at the positive electrode. We're carrying out electrolysis of aqueous salt solutions, and we're interested at the products at the positive electrode. So it's going to be the negative ions in solution that are attracted to the positive electrode. Remember, the rules are if the negative ion is in group 7, then we get the group 7 formed at the positive electrode. If it's not in group 7, then we get oxygen formed at the positive electrode. So the first one is copper sulfate. Sulfate ions are not in group 7, therefore we get oxygen formed at the positive electrode. The next one is sodium chloride. Chloride ions are in group 7, chlorine is in group 7, therefore we'll get chlorine formed at the positive electrode. Copper nitrate. Nitrate ions are not in group 7, therefore we get oxygen formed. Potassium iodide. Iodine is in group 7, so we get iodine formed at the positive electrode. And the last one, calcium bromide. Bromine is in group 7, so we get bromine formed at the positive electrode. Question 4 about electrolysis says state the product at the negative electrode. We're carrying out electrolysis of aqueous salt solutions, and we're interested in the negative electrode, so it's going to be the positive ions that are attracted to the negative electrode. Remember, the rules are if the positive metal ion is more reactive than hydrogen, we get hydrogen formed. If it's less reactive than hydrogen, then we get the metal formed at the negative electrode. So the first one is potassium bromide. Potassium is more reactive than hydrogen, therefore we get hydrogen formed. Second one is sodium chloride. Sodium is more reactive than hydrogen, again, so we get hydrogen gas formed. Molten copper chloride. Copper is less reactive than hydrogen, therefore we'll see the copper formed on the negative electrode. Potassium sulfate. Again, potassium is more reactive than hydrogen, so therefore we'll get hydrogen gas formed. And the final one is zinc chloride. Zinc is less reactive than hydrogen, therefore we'll get zinc formed at the negative electrode. Question 5 says state the product at the positive electrode. So we're carrying out electrolysis of aqueous salt solutions, and we're interested in what happens at the positive electrode. So it's going to be the negative ions that are attracted to the positive electrode, and the rules for this is if the negative ion is in group 7, then we get group 7 formed, and if it's not in group 7, then we get oxygen formed. So the first one is potassium bromide. Bromine is in group 7, therefore we get the group 7 formed, so we get bromine formed. Next one is sodium chloride. Chlorine is in group 7, so we get chlorine formed. Molten copper chloride, again, chlorine is in group 7, so we get chlorine formed. Potassium sulfate, the sulfate isn't in group 7, therefore we'll get oxygen formed. And the last one is molten zinc chloride, again, chloride is in group 7, chlorine, therefore we get chlorine formed. Question 6 about electrolysis says, explain why zinc ions move towards the negative electrode. So we're told that zinc chloride is an ionic substance. Zinc ions move towards the negative electrode, where they gain electrons to produce zinc. We've got to explain why. So first of all, zinc ions are positive ions. The negative electrode is negative, so therefore opposite charges attract, so the zinc ions will move towards the negative electrode and form zinc. Question 7 about electrolysis says, explain why potassium ions move towards the negative electrode. So potassium chloride is an ionic substance. If potassium ions move towards the negative electrode, they gain electrons to produce potassium. We've got to explain why the potassium is actually moving towards the negative electrode. So first thing to remember is that potassium ions are positive and the opposite charges attract, therefore the positive ions will move towards the negative electrode, where it will then gain electrons and form potassium. Question 8 about electrolysis says, explain why sodium ions move towards the negative electrode. We're told that sodium iodide is an ionic substance. We're told that sodium ions move towards the negative electrode, where they gain electrons to produce sodium. So we've got to explain why that they move towards the negative electrode. So first thing to remember is that sodium ions, the metal ions, are positive ions. So therefore, you say that sodium ions are positive, and we know that opposite charges attract. So the positive sodium ions will move towards the negative electrode. They'll then gain electrons to produce sodium. Question 9 about electrolysis says that sodium chloride can be electrolyzed. Explain why sodium chloride must be molten or dissolved in water to be electrolyzed. So remember, for electrolysis to work, the ions have got to be able to move. So being molten or dissolved in water will allow the ions to move. So we need to say that it's molten or dissolved in water because the ions can move, and they'll move towards the electrodes. The positive ions will move to the negative electrode, the negative ions will move towards the positive electrode, and remember that the ions are carrying the charge. Question 10 about electrolysis says magnesium chloride can be electrolyzed. We've got to explain why magnesium chloride must be molten or dissolved in water to be electrolyzed. So first thing to remember is that for electrolysis to occur, the ions need to be able to move, and the only way the ions can move is if they're molten or dissolved in water. So the first thing is we say that if the magnesium chloride is molten or dissolved in water, then the ions can move. They can move towards the electrodes. The positive ions will move to the negative electrode. The negative ions will move towards the positive electrode. And remember that ions are carrying the charge. Question 11, electrolysis says solid sodium chloride cannot be electrolyzed. Explain why sodium chloride cannot be electrolyzed. So we're told that the sodium chloride is in the solid form, and if it's in solid form, then ions cannot move. So we need to be saying that the ions can't move. We need to say where they can't move to, so they can't move to the electrodes, and if they can't move, then they can't carry the charge. Question 12 says solid potassium chloride can be electrolyzed. We've got to explain why potassium chloride cannot be electrolyzed. So we're told that it's solid, and remember, if it's solid, it won't form ions, and the ions are unable to move. So we've got to say that the ions cannot move, they can't move towards the electrodes, and therefore the ions cannot carry the charge. Question 13 about electrolysis says magnesium chloride can be electrolyzed. Explain how magnesium is produced at the negative electrode. So we've got to explain why the magnesium moves towards the negative electrode and what happens at the negative electrode. So first of all, we need to say that positive magnesium ions are formed and they're attracted to the negative electrode because opposite charges attract. When the magnesium joins to the electrode, the magnesium gains electrons, and we can say the magnesium ions are reduced. and because magnesium is in group 2, it gains 2 electrons. So it becomes from magnesium 2 plus to Mg. Question 14 says copper chloride can be electrolyzed. Explain how copper is produced at the negative electrode. So first thing we've got to say is that positive copper ions are formed and they're attracted to the negative electrode because opposite charges attract. When the copper ions reach the negative electrode, they will gain electrons. You can say that the copper ions are reduced, and copper will gain 2 electrons from Cu2 plus to Cu. Question 15, electrolysis says sodium chloride can be electrolyzed. Explain how sodium is produced at the negative electrode. So we've got to say why the sodium actually moves to the negative electrode and what happens at the electrode. So first of all, positive sodium ions are formed. They're attracted to the negative electrode because opposite charges attract. When they reach the negative electrode, they will gain electrons. We can say that the sodium ions are reduced. And because sodium is in group 1, it gains 1 electron. Question 16 about electrolysis says aqueous sodium chloride solution is electrolyzed in different industrial processes. Which 4 ions are present? So remember, if we're dissolving sodium chloride in water, that forms an aqueous solution. So we've got ions made from sodium chloride and the ions made from water, H2O. So the 4 ions present are sodium ions from the sodium chloride. We've also got chloride ions, from the sodium chloride. And then water will split into hydrogen ions, H plus ions, and hydroxide ions, which are the OH minus ions. So they're the 4 ions that were present for the aqueous solution of sodium chloride. So question 17 about electrolysis says aqueous potassium chloride is electrolyzed in different industrial processes. Which 4 ions are present? So remember, it's potassium chloride in aqueous solution, so we've got to say what ions are present in potassium chloride and what ions are also present in water. So in the potassium chloride, we've got potassium K plus ions, we've got chloride Cl minus ions, and then the water will form hydrogen H plus ions and hydroxide OH minus ions. Question 18 says aqueous potassium iodide solution is electrolyzed in different industrial processes. Which 4 ions are present? So remember, it's aqueous solution, so we've got the potassium iodide, but we've also got water. So the potassium iodide will form potassium ions, K plus ions, iodide, I minus ions. The water will then form hydrogen, H plus ions, and hydroxide, OH minus ions. Question 19 about electrolysis says aqueous potassium iodide solution is electrolyzed in different industrial processes. Which 2 other ions are present in aqueous potassium iodide solution other than potassium and iodide? So the thing to remember here is that if it's an aqueous solution, we've got water. We're already told about the ions in potassium iodide, so we need to talk about what ions water will form. So water will form hydrogen, H plus ions, and hydroxide, OH minus ions. Question 20 about electrolysis says aqueous sodium chloride solution is electrolyzed in different industrial processes. Which 2 ions are present in aqueous sodium chloride solution, in addition to sodium ions and chloride ions? So remember, aqueous solution, we've also got water present. So we're already told about the ions in the sodium chloride. So we need to talk about the ions that water would form. So water would form hydrogen, H plus, and hydroxide, OH minus. Question 21 about electrolysis says aqueous sodium chloride is electrolyzed, sodium hydroxide solution is produced. Explain how the sodium hydroxide solution is produced. We've got to refer to the process of the electrodes. So first thing to remember is it's aqueous solution of sodium chloride. We've got 4 different ions. We've got sodium ions, we've got chloride ions, we've got hydrogen ions, H plus from the water, and hydroxide ions, OH minus. So first thing we've got to say is that the sodium ions and the hydroxide ions are left in solution. The hydrogen ions are discharged or reduced at the negative electrode to form hydrogen, and the chloride ions are discharged oxidized at the positive electrode to form chlorine. So that's explaining where the 4 different ions are either discharged, reduced, or joined and left in solution. Question 22 about electrolysis says aqueous potassium chloride solution is electrolyzed in different industrial processes. Potassium hydroxide solution is produced. Explain how the potassium hydroxide solution is produced. Refer to the process of the electrodes. So again, it's remembering that aqueous potassium chloride, there's 4 ions. There's potassium ions and chloride ions from the potassium chloride. There's also hydrogen and the hydroxide ions from the water. So the potassium ions and the hydroxide ions are left in solution, so they join together to make the potassium hydroxide. The hydrogen ions are discharged or reduced at the negative electrode. Hydrogen ions are positive, so they'll be attracted to the negative electrode, and they form hydrogen gas. And the chloride ions are discharged, oxidized at the positive electrode, because chloride ions are negative, to form chlorine gas. Question 23 about electrolysis says aqueous potassium bromide solution is electrolyzed in different industrial processes. Potassium hydroxide solution is produced. Explain how the potassium hydroxide solution is produced. Refer to the process of the electrodes. So again, we've got to remember it's aqueous solution, so we've got 4 different ions. We've got the ions potassium bromide, which is potassium and bromine, and we've got the ions from the water, which is hydrogen and the hydroxide. The potassium ions and the hydroxide ions are left behind in solution, so they'll join together to make the potassium hydroxide. Hydrogen ions are discharged or reduced at the negative electrode. Hydrogen ions are positive, so they'll form hydrogen gas. And the bromide ions, which are negative, will be discharged or oxidized at the positive electrode to form bromine gas. Question 24 says sodium metal and chlorine gas are produced by the electrolysis of molten sodium chloride. Explain why sodium chloride solution cannot be used as electrolyte to produce sodium metal. So the key thing to remember here is that sodium metal in a molten version, we've only got 2 ions, sodium ions and chloride ions. So there's only 2 possible products, which is sodium and chlorine gas. Whereas if we use sodium chloride in solution, we've also, as well as the ions in sodium chloride, we've also got the ions in water, which is hydrogen and hydroxide. And if we carry out electrolysis of a solution with aqueous solution with water, if the metal is more reactive than hydrogen, then we get hydrogen gas produced. So sodium is more reactive than hydrogen, so hydrogen gas will be produced instead of sodium at the negative electrode, and that's because sodium is more reactive than hydrogen. Question 25 about electrolysis says potassium metal and chlorine gas are produced by the electrolysis of molten potassium chloride. We've got to explain why potassium chloride solution cannot be used as electrolyte to produce potassium metal. Well, if we've got molten potassium chloride, we've only got 2 ions formed. We've got potassium ions and chloride ions. Therefore, we will get potassium metal and chlorine gas, as the question states. Whereas if we use potassium chloride in solution, we've also got water. So we've got the ions present from water, which are hydrogen and hydroxide. The thing to remember is that if the metal is more reactive therefore than the hydrogen, we get hydrogen gas produced. Potassium is more reactive than hydrogen, therefore hydrogen gas will be produced instead of potassium, alright, because potassium is more reactive than hydrogen. Question 6 on electrolysis says lithium metal and chlorine gas are produced by the electrolysis of molten lithium chloride. Explain why lithium chloride solution cannot be used as electrolyte to produce lithium metal. Well, if we've got lithium chloride as a molten version, we've only got 2 ions, which is lithium ions and chloride ions. Therefore, we'll get lithium metal and chlorine gas, as the question states. If we've got solution, we've also got water, and therefore we've got the ions that are found in water, which is hydrogen and hydroxide ions. So therefore, we've got to take those into account. If the metal is more reactive than hydrogen, then there we'll get the hydrogen gas produced rather than the metal. Lithium is more reactive than hydrogen, so hydrogen gas will be produced instead of lithium because lithium is more reactive than hydrogen. Question 27 on electrolysis says hydrogen gas and oxygen are produced when sodium sulfate solution is electrolyzed. Explain how oxygen gas is produced in the electrolysis of sodium sulfate solution. So we're given clues in the question. We're told that it's sodium sulfate solution. So a solution means that there's also water as well as the sodium sulfate. So that will form the ions of H plus and OH negative ions. So the OH negative ions are what form the oxygen gas. So they're negative, so they'll be attracted to the positive electrode. So first thing we can say is that water molecules break down to produce OH minus ions. That the OH minus ions are attracted to the positive electrode because opposite charges attract. The OH minus ions will therefore lose electrons. We can say that OH minus ions are reduced, and therefore at the end of that, oxygen gas is then produced at the positive electrode. Question 28 electrolysis says hydrogen gas and oxygen are produced when potassium sulfate solution is electrolyzed. Explain how oxygen gas is produced in the electrolysis of potassium sulfate solution. So again, we're given a clue. We're told that it's a potassium sulfate solution. Solution means that it's in water, and we know that water will make the ions H plus and OH minus. We know oxygen gas has been produced, so we know that's going to be at the positive electrode, and it's the OH minus ions that are therefore going to be attracted to the positive electrode. So we can start off by saying that water molecules break down to produce OH minus ions, that the OH minus ions are attracted to the positive electrode because opposite charges attract, that the OH minus ions lose electrons. We can say that OH minus ions are reduced, and therefore oxygen is then produced at the positive electrode. Question 29 electrolysis says hydrogen gas and oxygen are produced when potassium nitrate solution is electrolyzed. Explain how oxygen gas is produced in the electrolysis of potassium nitrate solution. So we're given the clue in the question. We're told that it's potassium nitrate solution, so we know it's in water. We know that water forms the ions H plus and OH minus, and the oxygen gas is being formed by the OH minus ions being attracted to the positive electrode. So we can start off by saying that water breaks down to produce OH minus ions, that those OH minus ions are attracted to the positive electrode because the opposite charges attract, that the OH minus ions will lose electrons at the positive electrode. We can say that OH minus ions are reduced, and therefore oxygen gas is therefore produced. Question 30 on electrolysis says copper and chlorine are produced when molten copper chloride is electrolyzed. Complete the half equation for the reaction at each electrode. So we're given part of the half equation. We know we're starting off with the copper ions, which are Cu2 plus, and we know at the negative electrode the copper 2 plus will be attracted to the negative electrode and it will form copper. So we've got two positive charges, so we've got to balance out the positive charges, so we need two negative electrons, and that will form copper. So Cu2 plus 2 electrons negative will form copper metal at the negative electrode. We're then told part of the half equation at the positive electrode, so we know it's a positive electrode, so this is chlorine ions being attracted to it, and we know that we're starting off with two chloride negative ions. So we know we're going to form chlorine gas, so Cl2, and we know we've got two negative electrons extra here, so we need to lose two electrons. So it'll be 2 chlorine negative forms chlorine gas, Cl2, and two negative electrons will then be released. Question 31 on electrolysis says magnesium and chlorine are produced when molten magnesium chloride is electrolyzed. Complete the half equation for the reaction at each electrode, and then we're given a part equation for the negative electrode and the positive electrode. So first of all, looking at the negative electrode, we know it's going to be the metal ion magnesium 2 plus that's attracted to it. We know we're going to form the metal magnesium, and we've got a positive charge of 2 plus, so we've got to balance that positive charge out with two negative electrons. So it's Mg2 plus 2 negative electrons makes Mg. We've then got the second half equation at the positive electrode, so we know we've got chloride ions this time being attracted to the positive electrode. We know we're going to form chlorine gas, Cl2, so we've then got to lose two electrons to form that chlorine gas because we've got two negative electrons on the chloride ions. So it's two chlorine ions goes to Cl2 gas plus two electrons will be lost. Hope you found these useful. Please subscribe and I'll see you next time.